Hi, Ron. Good morning.
Good morning.
We're going to continue from where we stop. So I will share my screen now. Do you see my screen now?
Yes.
Great. So where were we? We were talking about, last time we stopped in talking about DKL, remember?
Yes.
But let's remind
That's
ourselves.
the measure of a distance. One of
Yeah,
the
measure
possible.
of a distance. So we had the loss function, which is the measure of a distance, which takes, it has with respect to a certain cloud of points, which takes the parameters, right? And is defined by softmax. Softmax is a normalization of exponent, right? Softmax of a linear function, right? Of W, which is the matrix, multiplied by our vector, which represents oh, I forgot something important. What did I forget?
The loss is the average of the.
Yeah, exactly. So here I have a summation of, I will choose K instead of I because I'm going to use I for something else. So K is running on all the samples. We had capital N samples, and we're going to divide everything by N. Right? That's our loss function.
I don't think so.
No. Sorry. I'm completely
You
confused.
need the distance between.
Yeah. Well, I'm completely. That was the definition of our function. So what we need is something like this. It's interesting what just happened to me. Maybe it's beginning of the dimension, right?
Capital N. Capital N.
Thank you for that also. You might have think it's in the middle of the night, but it's morning. Capital N, K runs from 1 to a capital N. And we are talking about H, which is cross entropy between two probabilities. One is a YI, which is my labeling, YK, sorry, YK. And the other one is, do you remember?
The softmax of F. Okay.
F of W of X, which is a vector, right? K. So this is our loss function. And before I was
Now
confused,
it's
and I
important
started writing the definition of F. What did you want to say?
that it's important. So if anybody loses you, you should just understand what's written there with the H guy, which is a bit mysterious.
Yeah, I'm going to talk
Is
about it now.
it's a
The cross
distance.
entropy.
You could use other distances. You like this one.
Yes.
Your prerogative
Yeah,
to like this one. But it's a
right.
distance between YK and FW of XK.
Exactly. Yeah. Distance between Y I, which is the probability. This is actually a deterministic probability, right? And this is not deterministic probability, which is the output of my neural network or my function.
Just YK, right? Not YI. Okay.
Sorry. Thank you. YK, and this is XK. Yes, so it's a measure of distance between two probabilities, and you are completely correct that I've chosen cross entropy, but I could have chosen different measure like L2, for example, or other probabilities distance measures. Okay, but I've chosen cross entropy, and I want to talk a little bit more about cross entropy and DKL. That's what we started doing last time. Okay?
Okay.
So DKL, just to remind you, gets two probabilities, right? P1 and P2. And we had an intuition for it as a redundancy. We said it's like cross entropy. That's what we did at the end of our last discussion of P1 of P2.
And I liked very much your metaphor last time. It's suppose P1 is the distribution of words in English, P2 is the distribution of words in French, and H is some measure of how hard it is to deliver information.
The expected length of encoding.
Precisely.
In bits.
When the speaker thinks it's French and actually uses the distribution in English.
Yes. So here, the true probability is P1, which let's say it's English, but you are mistaken and think that I'm talking in French. So and this is this part. You encode my English speaking as if it was French. And this is a optimal encoding, which is my English speaking as if it was English. And the difference is the amount you waste because you are wrong.
That's the distance between the two, some distance between the two distributions.
Yeah. If you would think that my English is English, this would have been 0, right?
Yes.
Yeah. Okay, great. And in our loss function, which is P1 and which is P2, so actually we are dealing with the distance, DKL, of YK and FW of XK, right? But Y is not just a regular probability, it's a deterministic one, right? It's a labeling.
That's the actual picture that you see there.
Yeah, it's a
picture, the actual identification.
It's either this probability,
yes, dog,
or this probability, not anything else.
Yes.
So it's a special case. So what can you say about, and this is like itself like P1, right?
Mm-hmm.
This is my P2. Mm-hmm. So what will happen? Because the YK is deterministic.
It's going to be non-zero, what do you mean? Usually.
What will be the value of this?
HP1 is going to be 0.
Yeah, exactly. So let's write it. So it's H of YK, right? Of F of FW of X K.
Yeah, that was your original definition.
Exactly. I did that only to show you that everybody talk about cross entropy, but it's actually DKL.
Yes, okay. DKL is defined by cross entropy. Okay.
You can say that. Just a minute. And this is H of YK, right? And this is 0, right?
Yes.
Okay, so if we look back on our definition of loss function, we could have written here DKL of yk it would have been the same. So we could have said, instead of cross entropy, we're using DKL because we are dealing with deterministic probabilities. It's the same. Okay, so, and DKL is a very, very common measure of distance between probabilities. Okay, so I think we're ready for some derivation, because in order to, we're aiming to actually code this. We want to code this in a simple computer program that actually will distinguish a dog from a cat. We are very close to it. The only thing that we miss is the partial derivatives. So now we're going to start.
From here now, I will just believe you that you know how to differentiate.
You don't want to actually do it with me?
To go through differentiation? Okay.
Yeah, let's do it.
It's really interesting.
Actually, I might need your help because it's not so easy. Let's see. So we are differentiating log. Just to be honest, generally, people of my kind don't do it. They have a special package.
Sorry,
all the derivation is done for us. So that's why I'm not very skilled. Let's try anyway. We are deriving loss according to some way. What?
Wij.
Exactly. Let's just remind the viewer that what is W, you remember?
W is a 2 by n matrix.
Exactly. 2 by not capital N, right?
No.
And, yeah. It's a 2 by, because it is multiplied by a picture, right? By a vector of a million pixels, right? N is a very big number. Okay. This is 1 over, this is N over 1. Okay, fine. I will delete that. This was a reminder of, okay, so let's start doing it. We start by the definition of loss, right? Definition, okay, this is 1 over N of H Y K F. I will drop the notion of vector just to make it easier for us. Right, this is the definition?
Yes, and okay, and F is not so simple because it's a composite function.
Yeah, it's not simple. Now you understand why I chosen to use the K instead of I, because I want I to be here.
Sure.
Okay, so let's use the linearity of derivation, and we'll put it inside. K runs from 1 to capital N. And we're going to derive H of YK. It's kind of verbose. I have to write a lot, but it's not something deep, right? Nothing deep here. Just
we all learned how to differentiate. And
what?
We all learned how to differentiate.
All of us, but some of us forgot.
No.
You, me. How many times did you teach calculus courses?
Infinitely many times, yes.
What?
Never differentiate there. But never mind.
Okay, now I will use the definition of cross entropy, right?
Mhm.
You can go to sleep. What is the definition? So it's a derivation of, it's the expectation of, okay, so it's y k1. You understand what I mean by yk1?
To
Yk
remind
is
the listener,
the first coordinate.
yes, and
Multiply, let me put a minus here to be more, to write plus log. So this is log of f of x k, and please allow me to write something like this. Okay, this is the first coordinate of, because the function gives us two coordinate vector, right? So it's the first coordinate. Are you with me?
yes. So it would be best if you wrote somewhere in the corner what is the cross entropy, what is Kullback-Leibler, because
Okay,
the
fine,
listener doesn't
okay.
remember.
This is a good idea. I can hear Talmas from your voice.
Okay. But are you sure we need it? I mean, all listeners know how to differentiate. There is an exponent at the end.
None of them knows how to do it. Even I
Differentiate
don't know.
exponent. Okay.
Yeah, it seems tedious, but I do want to do it.
Okay.
You're gonna see that I'm getting stuck. So I don't want to run over. It seems tedious, but I think it's important. So is that correct? Like P1
Log of P2. And there is a minus sign.
I'm not sure I should have written K here.
No, it's okay. Yes, it's precisely.
Maybe I would have been a better
Log
pick.
P2. Okay.
That's the definition of cross entropy.
There is a minus before.
Right. Thank you. Okay, that's the definition of cross entropy, and I just applied it here to our. So remember, we are dealing with the cross entropy of y and f of x. So it's only two. This summation is over two, and this is y k 2 log f2 of x k. What is the special about y?
It's 1 and 0. So one of the y's is 1 and one is 0. Right?
Yeah, one of them is 0 and one of them is 1, right?
Yes.
So
Yeah.
it makes the things simpler. Let's, I think I should let's define something like that. Like the index, which is, I will define something like that. Yk, let's call it tilde, will be either 1 or 2. 1 or 2. It will be 1 if yk is a dog. And 2, if you understand what I'm doing it, I
I
want
don't think it's a good notation because y tilde k suggests that it's a vector.
tilde suggests it's a vector.
Because it's like yk, it's a variation on yk.
Okay,
That's what you expect.
instead of tilde, what have you Is hat a better way to
Call it
pronounce it?
IK. Call it IK.
Pardon?
Call it JK or something, or some TK.
Ah, JK.
It's a number, so
yeah,
it's
right. Like an index. Yeah, great idea.
call it
Okay.
TK. Say. Because Y and J are very used.
What's wrong about JK? Your previous.
Don't you have WIJs there in the? Yes, you have WIJs.
I have J. Okay. So TK. Okay. Sorry about the mess. This is completely erased. And small t or big T?
Yeah, I don't know where you're heading, so let's see.
Okay, small k is the index. I wanted to stress that this, one of them is 0 and one of them is 1.
Yes.
Right?
Okay.
Which one is 0 and which one is 1? TK.
Yes.
Okay, so I will continue here. I want to see everything. You know what I can do? I can go away.
Okay.
My computers are great, right? And so that was just a notation. I will write it like that. We have minus 1 over n, right? This is k. And here, all we have is d of t. No, we have 1, so we have only log. We have only log of f of tk. That's my God.
That's right. F of x tk. F.
I think I'm correct.
Yes. ftk is just the tk coordinate of f. F, you remember, is a vector. F of x is a vector.
Yeah.
And we're just looking at the non-zero.
Exactly.
The part in which y is non-zero. Yes. Okay.
Yeah. Okay. So we're okay now?
Yes.
We hope so. Okay, so let's continue. We know how to differentiate the log function, right? But it's we need the chain rule here. So
okay.
This is k.
Oh.
This is 1 over f t. I know it is tedious, but I think it's important to see it's kind of complex. And now we need to derive the inner function, right? Which is f of tk of xk. Okay. Now, I don't want to mess with all this, so let's focus on this term and try to derive it. You remember what's the next? What is
e to the something? E to the.
Exactly. Yeah. So let's say we have this f of w of x k is the softmax, right?
Mm-hmm.
Of w x. Let's call this vector z1, z2. Okay?
Mm-hmm.
And what's the softmax is? So we have
e
to the power of z1 divided by e to the power of z1 plus e to the power of z2, right? This is the first coordinate of the vector. And the second coordinate of the vector is e to z2 divided by the same thing, right? Is it too much for you? Like,
I'm not sure how eager the listeners will be to follow all this.
maybe it should be an appendix or something. Oh,
Yes, I think so, that you should give
okay,
the final answer, and then whoever wants it, here is the derivation for
okay.
the non-believers.
Okay, let's put I will just write one more thing and then we'll put 3 dots. So what do we have here when we continue? We have, I will just do one more step. I don't want to tire everyone too much. Maybe I'll just write.
There are free agents. They can leave if you tire them too much.
They can do much more. They can skip ahead in YouTube.
Yes.
Which is great, and they can also pick. This is what's so nice about the learning from the internet. I want to say that here we have this f of tk, and here we have a derivation of whom? E, just one of them, right? Because of tk, e to which z of tk to the e of z1 plus z2, all this. Okay, so this is another step. What will be the next step? I won't write it down, but we need to.
I'm confused.
Yeah.
Z is this FW, right? Only the one coordinate.
Z is wx.
Yes. But TK is just the TK coordinate.
TK is the coordinate of which
Y is non-zero.
Y is not is 1. Yes.
So
yeah.
the W appears also in the denominator, right?
Sorry, W?
Wij appears both in the denominator and
yeah, right. Like here we have a divide of 2 functions. We need to use the derivation of function.
quotient, yes.
Yeah. Yeah, it's kind of tedious, I agree. But let's put 3 dots here. Actually, I don't remember the final result, but I will compute it.
I'm not sure it's so important. I mean, the computer will
It
know.
is important. We need it for the programming. We need to know a formula for the derivation to perform gradient descent. We need to compute them. It's like practical things, right? We want to do gradient descent.
I thought that the computer knows how to do such things as well, but
but I don't want the computer to do it. I want us to write it from scratch. I could have used packages that do everything for me, but I don't want to.
Okay.
So we're going to use the formula. We won't compute it, but we use the formula and compute a gradient descent. Let me show you what we're going to. How much time do we have left in this lesson?
I don't know. I don't have
the time we have. Okay.
What time is it now?
It's 35.
Okay.
35. We have some time. I'm going to start showing you the way we're going to program it. Just a minute. We're going to use a tool called Colab. Have you ever heard of it?
No.
It's really nice. It's online. You don't need to install everything. And you can just start coding with Python. I will show you. You know some Python?
No, no, no.
Okay. Any programming language?
I learned to program in PL1, which you don't even
PL1.
know exists.
Great. It's the same thing. It's equivalent to Turing machine.
Okay.
So we're on the same page. It's all the same, really. No different. For I in range, you never learned Python, but you will understand that.
Yes, well, it seems self-suggesting. So.
Any idea what this program will do?
10 times hello Ron. No?
What?
It will write 10 times hello Ron.
Great. You see, you know Python.
Okay.
And I will add something. Why are you laughing?
He will know how to do that. He will know how to write in the first I equals 1, he'll write once, I equals 2, he'll write twice.
This is not what I've done. We can do what you said.
No. I want to know what you've done. Star is product, right? Times.
Yeah, it's product, but it's a product of a string.
Yeah. So it's,
did you ever define a product of a string with a number?
No.
It's concatenating.
Concatenating this string, not the number. Yes. Okay. Yes, that's what I thought. So we'll say hello Ron, hello Ron, hello Ron.
Can I run it? Can I run it?
Yes. Okay.
Okay, I will run it.
Why is it slanted?
I just indented it.
Yeah.
I will. Maybe I should have written it in a more. Maybe this will be clearer. I did I spaced it at the beginning and then wrote hello Ron.
Okay. I spaced this.
Okay. I multiplied the space.
Yes.
But let's do what you suggested. You suggested something like hello Ron.
10 times.
I time or 10 times? What do you want?
10 times.
10 times?
I. What's
Okay,
written
so let's run it again. Fascinating.
Yes. Life of programmers has become much easier now.
Incredibly easier than it used to be. Yes. Because you had to compile, right? You had to, yeah, it's much easier. And it's fun.
I'll switch profession too.
Now is the time. Now is the time. Okay, so what we want to do is to use a data set of cats and dogs. I've already looked for one, and I think I found it. Let me show you. Let's open it. This is a terminal window. I will, I think I download it in, let's see. Okay, you see here, I have many.
You have met?
I have many pictures of dogs and cats. Let me show you. This will be cat number 11. Oh, just a minute.
You mean it's already programmed, all that you told us?
No. I just downloaded many pictures of dog and many pictures of cats. Let me show you. Mm-hmm. This is a cat. This is a cat. Can you see it?
Yes.
This also shows you how difficult it is to actually write a program that makes that identifies cat from a dog, because so many different, right?
Yes, amazing.
And
And it fills one with respect to humans who know how to differentiate between the two, right? To tell dogs from cats.
I know. Do you
We
know?
are very clever. I didn't know how clever we are. We are.
Until this very moment, you didn't know how clever you are?
How clever all humans are. Amazing.
By the way, my dog cannot do it. Like when I show him.
Cannot tell on a picture. No, he doesn't care for.
Yeah, he needs a smell or 3D image or sound.
A little distraction. Our dog doesn't need to smell. We drive yours as well. We drive in the car. If he sees a cat, nothing. If he sees a dog outside, she just gets crazy because she wants to protect her territory. So she can tell dogs from cats by sight, only by sight. There is no time for smelling.
Did you publish an article about
it? Why should I?
You just discovered something really important.
This is really, I mean, it's really interesting. How can she tell? But
yeah,
she does. Wow.
It is interesting. Also, we know very little about the way our brain function. We know very good about the functioning of a single neuron in our brain, but the net of neurons is something we don't fully understand, not at all. So you see, these many dogs, it won't be easy, right? Like for you, it's easy, but to formulate how you do it, it's very difficult, right?
So and do you think that at the end of the day, we're going to have a program that does it?
Yeah.
Okay.
It's kind of a miracle, isn't it?
I'm looking forward.
But not today.
I'm sure somewhere there is, of course, there is somewhere on the net.
But we're going to build a program that does it pretty amazingly. Nowadays, you can write a program that does it better than humans.
Really?
Yeah.
I mean, find on the network, or you can write on your own.
I can
on
write
the network. Probably there is. I'm sure. I mean, Google will do it for you immediately.
I don't understand. What?
I'm sure that on the network there are many.
No. I mean, we're gonna program it.
Yes.
And but I'm not sure our program will be better than human because it depends on the data set. If it's big enough, if it's diverse enough.
Yes.
Okay, but it is a big challenge. Like 15 years ago, nobody could have done it. It's something new that people actually managed to do it.
And of course, it's much harder to write a program that tells between your picture and mine. I mean, okay, you have a bald head, so it's easier but that recognizes you from the age of 3. You give of course, you give them a picture of your as a baby, and it will tell you that's you.
Did you just say that face detection is a more difficult task than distinct classification of dog and cat?
I would think so. For humans, it's harder.
It will be the same for us to write such a program. It will be, and if you know how to do what we are doing, you can easily write a face detection program. I think we're gonna stop today.
Okay. And I also
next time we're gonna take the derivative and start programming. Okay.
Okay. I'm away tomorrow and Friday.
Saturday. We'll schedule.
Okay.
So I will say goodbye now and we'll schedule.
Yes. Okay.
Okay. Thank you.
Bye-bye. See you.
Thank you. Thank you very much.